screen, I can't even tell if people are around or not. That's why sometimes I usually want to see that interaction, because it usually happens to me most of the time. Like sometimes you teach and then you find out that it's been 10 minutes, 20 minutes, and you are dropped. You're not in the meeting. So this interaction I always like, because it helps me to know that I'm still on board, and also I have people following. So I hope it's recording, right? It's sharing
Yes,
and
yes, it's
recording.
recording. It is.
In case it drops, you can just notify me on WhatsApp. All right, great. So we want to learn about the model deployment, machine learning model deployment. And as we wait for some people, I just want us to remind ourselves about the machine learning, because also we are going to upload on YouTube, so it might find someone who is new to machine learning. So machine learning is just a subset of artificial intelligence. So artificial intelligence is the bigger, or maybe the broader field that, and then under it we have the machine learning. First of all, artificial intelligence, just as the word suggests, says, it's like the ability of the machines to perform tasks that requires the human intelligence. So machines are trying to do those things. And then we use now the machine learning techniques now to train these machines to do the same thing, and to do those things that should have been performed by the humans. And then under machine learning, it is divided into three broad categories. We have the supervised learning. This where, for example, you have the training set, and then you have the training set, and then you want the model now to predict based on how you've trained the model. I'm going to talk about it in details in a few, in a summary format. And then we also have another type, unsupervised learning. And this is just an opposite of the supervised learning. So this, you just have the input data sets, and then the machine now will be able to categorize it will be able to get now the response based on, for example, like how close is it? Is it in a class? For example, it is, in most cases it is a classification, not classification, but you want to categorize things based on, like I don't have that input. The training set, you have only the input, but then you want to predict the model without like a training, like you'll be using those classification, like you see how like the categories, like you want to group related things together, and then it will be predicting the models based on which group the response lies, or maybe which group it belongs. And then now we have another last one is the reinforcement learning. So this is now the machines, they make decision by performing something, and then it receives a reward. For example, if it is good, then if it's not good, then it will be given a penalty. So it's going to improve as it goes. So consider machine learning like a baby who doesn't know anything. For example, you want to train a baby to know this is a cat. So if it is the supervised learning, for example, you'll have a cat there. You'll say something that is small. It has 4 legs. It has a head and a tail. You can call it a cat. So in the future, when the baby sees something like that, then they are going to know that this is a cat. And then they are going to understand that that is a cat. So on the supervised learning, it is divided into two categories. Mostly I'm going to focus on this supervised learning. In fact, this one I'm going to focus more on the supervised learning, this project on the model deployment. So it is divided into two main categories on the supervised. We have those that involves numbers, the continuous data, and also we have the categorical. So on the continuous data, we'll be using the regression task, which involves like those continuous data, and then classification. Now this one involves grouping or maybe categorizing things together. So that one uses the classification models. And let me show you an example from the Explore. We are going to use one of them. And I remember, first of all, that in regression, the metrics are different. Perhaps on the regression, we usually use now the metrics that we use there. It involves, for example, things like the RSS, root mean squared error, root. Okay, let me draw something so that I can illustrate with some example. So on the regression, this one involves like a continuous data, like a number that goes to like just go continuous. It's not like limited. So you can use now this regression. For example, if it is a linear model, like the distribution is linearly distributed or a normal distribution, you can use this a linear model. And then, for example, if it is, for example, you want to predict the rainfall distribution, you know that rainfall is not contributed by humidity alone. You might have other factors like a temperature and other things. So if there are several and that they are both linearly, like they affect the rainfall distribution linearly, then you can use another model called multiple linear regression. Remember, these are several linear model. So you'll be using things like the multiple linear regression. And then, for example, if the data is not that linearly distributed, you can use for example, if data is not linearly distributed, you can use different models. Like, for example, if it's not linearly, like something like this, you can choose to use decision trees or even support vector machine regressor or a support vector machine, but then focusing on the regression. Remember, it can handle both the classification and also the regressor. So you can choose to use whatever it is. For example, if the data is not that linearly distributed, then you might choose to use whatever model it is. For example, if it's decision tree or whatever it is. So we have, so here we'll be measuring like the accuracy of the model. We are using this residual. Residual is now the distance between now the predicted data and the actual data, like this line of best fit to the these points, these data points. So this distance is called now the error or maybe the residuals. So for example, if I want to get now these the metrics here, you can use, for example, the root mean squared error, because now when data is here below this line, it is under the negatives. And then, for example, if you want to total all of them and then you have the negatives, then the negatives will be counted in the positive. So you usually square to remove the negatives so that you can get now the totals. And then if you want to now get, for example, the mean, you can use the mean absolute error. Mean absolute error, like the errors that you have, you've squared all the errors, then you get now their mean. And then, for example, because now the numbers are going to be big, you can as well scale down, and then you can use root mean squared error, like now to get it in the same units, like the same units with the original data set. So on the regression, we usually use those metrics, the RSS, the mean absolute error, root mean squared error, and all that. And then another one is the classification. Now on the classification task, we usually use because now classification, this one you want to categorize things. For example, if you want to know if someone is a boy or a girl, if someone is a boy or a girl, like you have two distinct features. So you can use, for example, something like a logistic regression. Now, if your input, so here you have just 0 and 1. Perhaps you can have 0 to represent, for example, girl, and then I want to represent a boy, and then you have the midpoint here. So, for example, if the distribution, like, or maybe the points, or maybe the predicted is below 0.5, here the midpoint, then it's going to be are pushed downwards. So like you'll find the data is going to be this way. And then, for example, if it is above 0.5, then it's going to be this side. First of all, let me do something like this. So you can tell that here you cannot use that linear model, because you can tell that this distribution is it's not that, although it is following the linear, some sort of linear, but now it is forced. It is rounded up or downward. So you have this distinct, like you have these groups. So here you can use, for example, the logistic regression, something like that. On this one, to get like you are forced to either push down or you have distinct features. For example, if the prediction like is above 0.5, then you are going to force it to, you are going to round up. And then if it's below 0.5, then you are going to round down. So here you can tell that you won't be using those root mean squared, okay, the residual, because you can tell that even if the data is here, it's going to automatically be forced to be here at the top. So that one is not going to work accurately. So here you'll be using things like, for example, accuracy, precision, for example, F1 score. Remember, accuracy is now, for example, how good was the model at predicting, for example, the positives, or for example, the one. Like how good was it to predict what is right? For example, if it is one, like you have, remember this one is under the supervised learning. Like you have already the training set. You have the training set. Let's say these are your features, X, Y, Z, and then this is the response. Let me use R. So you have this data, and then you are using now to get this value. You have this data, and then you're using to get this value. Now, so now when you train the models, you're going to split this data partly into training and a small percent into the testing, perhaps assuming these are the record for the testing. So you already have what? The response. But then on the training, you are using what? These are response. You have the training set, and then we also have these are prediction. You're training the machine. For example, if it's a baby, you're training the baby. Like you can tell, for example, this is a leg, this is a body, this is a head, and then this features is for a cat. And then, for example, you have another one. For example, this is a big leg, this is a big body, this is a big. It has horn. Then this is a cow. So you have these features, and then you have the response. Then now, when you want to train now to test the machine, so you have these features. You already know the answer, but then you are not giving the model, like you want now the model to predict if it is a cow or a dog. So here you will be like the machine will be giving its results. So you'll be comparing like from your original. So you'll be saying, for example, how good is this machine at predicting if it is, for example, if it is a cat or a dog. So you'll be comparing. So you'll be using now the accuracy, like how accurate is it at predicting or knowing that it is a cat. That is accuracy. Then you also have something called the accuracy. Then we also have precision. Precision is how good is it at doing the right thing, or maybe getting it right. Like the machine getting it right. And then we have recall, like how best is now this machine knowing that this is not right. Like how is it able to distinguish to know that this is not right and that this is right. Remember, for example, if you are developing a system to detect the fraudulent transaction in a system, you know that in most cases, there are rare cases of those fraudulent transactions. So how good is this machine to know the accurate or maybe good transactions? So because most of the time, the transaction are mostly pure or maybe good, so the machine is good at knowing the good transaction. So now the recall is now trying to understand, like the recall metric is trying to understand how good is it to know that this is good or this is bad. And then F1 score is now the ability of the machine now to generalize both the precision and the recall, like to know what is right, and then also what is wrong. You can call recall like the ability of the machine to know what is not right. Like you combine these things, so it will give you now the F1 score. So those are the metrics that I used on the on the on what on the classification task. So actually, I've been just talking on that when I wait for people to join. I think we have a quorum now. So, so those are the things that are involved in the machine learning, supervised learning on the regression and classification. We said that classification involves categorizing data, like those kind of categorical data. And then regression, this is just continuous data. And we talked about the models that can be used there, including the linear model, the multiple model, multiple linear multiple linear models, and then the decision trees. And then also, by the way, we have another one called ensemble learning. Ensemble learning is like trying to combine several models and then get the output like one result, like the best result or maybe the optimum. Remember this model on the linear, for example, if it is regression or a classification, like when you split the data into testing, training, or testing, is going to select data randomly. It's going to select the random data randomly. In fact, let me just find something so that I can illustrate well. I'm going to use this data from Explore. So let me trying to. Yeah, so now, as I was saying, in simple learning, like sometimes because we are selecting data randomly, sometimes you might find yourself that, or maybe the machine has selected only the bad ones, like those that will have those are biasness. So one model will not be that perfect. So you have this ensemble learning, like for example, you want to train, for example, if it is a decision tree, like you want to have several models on the decision trees. For example, you can have around 10. And then now, if it is in regression, you're going to get now their average. So you're going to settle on the average result so that you can settle with it, so that you can determine if it's best, your model has performed best or not. Like you're going to take now their average. And then, so if you take several trees, for example, if it's a decision tree, several trees, and then you get one output, then that's called the homogeneous learning, ensemble learning. Remember, ensemble is like you are combining several things together to get one output. That is ensemble learning. And if it involves just one model, like for example, decision trees, several decision trees, then that is called the homogeneous learning. And an example of it is like the random forest. It involves like several decision trees. And then now we have the heterogeneous learning, like it's trying to involve several machine learning model. For example, if it is regression task. For example, you take the multiple regression, you take the support vector machines. Remember, support vector machines can work both on the regression task and also the classification task, and also decision trees. So you combine all these different type of models, and then you get one output. Let's assume that you are in a class, and then, for example, for you, you are good in Swahili. Another one is good in science. Another one is good in did I say mathematics? So, and then, for example, if you are good in mathematics, you're not good in Swahili. So you are trying to combine all your knowledge so that each one of you are going to share so that all of you will have the same knowledge, and then get so that you can perform, you can perform better. Like for example, if you're a class, you have one best student, and then the rest are not that good, then you can notice that the mean score of the class is going to reduce. So the ensemble learning in the heterogeneous. Now, in the case of you are taking Swahili, mathematics, and all that. So you're trying to like teach each other, and then all of you have the same knowledge, and then you can give out the best, the results. So that is on the ensemble learning, and most cases you'll be using such stuff. So I want to show you the model deployment, and I want to use this example from the Explore, and this is the datasets that we are going to use. Okay, this is the notebook that I'm going to use. Remember, I'm not going to focus into machine learning and stuff. I just want to focus on the model deployment. First of all, I want to go through this thing quickly. So machine learning, you need to first of all import the packages necessary for machine learning. Like a NumPy involves a numerical Python, handling the numerical part of Python and all those mathematics. Then pandas, this with the data manipulation, data cleaning, and all data related stuff, data handling that is. And then the sklearn, this is for machine learning stuff and also classification and many other things, but are relating to the machine learning. Where, for example, the standard scaler, for example, let's say you have the rainfall. Okay, let's say you want to create a model to predict, for example, the weather pattern, or maybe let's use an example of the rainfall distribution. You might find out that, for example, the unit like humidity, there's a number that is used. For example, if it is in millimeter or whatever, and then you have, for example, the temperature it has its tools that are used. Okay, this, what do we call it? Like it's measurement, like those things that measures the temperature, and you have other things like, for example, if it's the soil, you'll be checking things like the pH value. So you can find out that they are in different units. They are in different units. So for example, if you want to scale down these models, and then you want to, okay, like let's say you want to introduce a particular thing to punish these things, or maybe let's say you want to to put them on the same, like I try to reduce, for example, the number. Let's say uko na number 1 million. Let's use currency. You have 1 million, and then for example, another unit is measured in 1,000, and then let's say another one is in, for example, tens. So for example, let's say you want to reduce that 1 million to a number that is commonly like that you can use well on your machine. So for example, let's say you want to use a number to minus, to subtract a number like, for example, 999,000 and all those numbers. So you can see that it's going to punish these small numbers very severely. So the standard scaler is trying to like introduce a common value. Like for example, it will take like that maximum number is going to be 1. For example, if it is in standardization or normalization, that is, you take that number, for example, if it is 1,000, you're going to give it 1. And then, for example, if it is in regression, like you're going to take like that where you have like the maximum regression, like a maximum residual, like the very highest distance. And then you're going to also take the smallest distance, the smallest residual. So you'll be taking that maximum to be 1, then at the smallest to be 0. Then every other values are going to be in the same unit, like all other values are within that range between 0 and 1. So that, for example, if you want to penalize, like they both share the same scale. So this is the work of the standard scaler. And then this is the data set I think that is used here. We're going to use this one. And then this is the train test split. For example, if you only have one data set that you want to use it on the training and testing. And then now this is the model that we're using now on this classification. Hopefully there's random forest, but these are the tools that we are going to use. And then these the data sets. And then here we have viewed, not viewed actually. Okay, here we have displayed like the head, or maybe the first 40. So you can notice that this is a machine. This a data set that involves the data on this. What is it? Sorry. It is iris data set. It is an iris, so I think it has to do with it has to do with. Okay, yeah, I think it is a plant. Yeah, it is an iris plant. So here it is trying to give, for example, the sepal length, sepal width, petal length, petal width, and then a species. So these features are going to determine which species it belongs. And then I can see it's mostly in one category. In one category, like here, iris, setosa, setosa, setosa. So if it is in this format, for example, if it just give you one species, then you'll be using like things like the confidence level. We'll be using the confidence level on the classification scale, but then we'll be using things like the confidence level, like the probability. Like I will be using now that those nini, the accuracy. Like for example, how confident is it? For example, if this numbers is given out, for example, iris setosa, so we'll be checking if it is very accurate. How accurate is it? For example, if it is below 90%, then we can know that it has given us iris setosa, but we are not that confident with the output because I can't see two distinct feature. So we'll be using those confidence level, and then so these the data sets. You can notice that we have different features. We have different features, but then in machine learning, if you want to train the model, you only need to have in some sort of a series. Like you only need to have the x and y. You know how those how do you call it? That graph it is usually drawn. You have the x and the y. So in this case, in most of the time, you'll need to flatten. You'll need to flatten this table so that it can be just in one, so that you can just separate, for example, the predictor, the response from this other predictor. And these are the feature variables from these the response variables. So the first part you need to detect, first of all, you need to identify what column are you using for your response variable. In this case, it is species. So here we are extracting the species data from this data set. These are variable for this data set. So from that data set, we are extracting this column called species. And then the second part here, we are trying to do it. We are trying to use now the rest of the columns. We are trying to use, remember, okay, so the second part, we are trying to use now all the columns. And we will be excluding these species because already this column we are using it for the prediction, the model prediction. So we are using now the drop here to drop these what do you call it? The species column. Then you notice that the values here are in different units. Like for example, you can see the sepal, it is in 5. This one ranges between 3, and then this is 1, then this is in 0.0 or whatever. So you need to have a common scale such that, for example, if you want to penalize or do anything, it will affect each of them equally. So here we are introducing this standard scalar, which is going to like standardize everything. And then here we are fitting like this is just a model that we have instantiated to create an instance of this standard scalar library to create an object or an instance. Okay, we are trying to instantiate this standard scalar or create an object. So when we create the object, so we are trying to do what we are trying to standardize these columns. So when you pass here x, it's like you are passing all these columns, excluding what? Excluding the response. Remember, the response you don't need to scale down because that is the response. And then here we are using the train test split now to split our data sets into testing. Okay, training and testing. And then you usually specify the test size when you say, for example, the test size is 30, then the training is going to utilize 70%. And then because it's going to generate like to select those columns, those observations randomly. So you'll need to introduce a random state. And I remember this 50, this number here is just an arbitrary number. You can add in anything, for example, 10, 42, whatever. But at this random state, when you use it here, you're trying to, because you're going to generate those data randomly, the training and testing. So when you introduce the random set, like it's trying to maintain that randomness that it has generated so that you can reproduce the same result. So here we are trying to, okay, so here we are trying to use now, first of all, here we have this just, here it is standardization, and then here it is, okay, this is standardization, then here we are trying to just split the data. So, and then a decision tree also we are trying to instantiate. Now, remember the decision tree and the algorithm that we are using in this case. And don't forget that in machine learning, all these steps you must follow. First of all, you need to have the data, and then you do the, once you have the data cleaning, you can do the EDA to understand the data, how it is, the nulls and all that. And then you clean it, you do the data cleaning. And then once you do the data cleaning, you can do some wrangling, data wrangling, like I try to restructure, to modify the data to be in the format that you can use it. And then once you do that, then you must do the visuals. You need to have the data visualization skill so that you can know the distribution of the data, so that you can choose, you can know which machine learning algorithm to use. For example, if the data is linearly distributed, if it is linearly distributed, then you are going to use the linear model. For example, if it's not linearly distributed, you can opt to use, for example, the decision tree or random forest, or you can use the support vector machine. So you need to have those visualization skills. But in this case, we are not going to focus on that. But once you have that, remember this one, we're using the data that's already cleaned and it's good for the model. And then, so here we've created the model. Like once you feel like the visualization is good, you're settled with the visuals, and then you've seen how the data is distributed, and then you have chosen the algorithm to use, then you can proceed. But remember, if you are unsure about which model to use, then you can use a technique called the ensemble learning. We talked about that. Like you can try to incorporate several models. For example, the linear models, the decision tree, and support vector machines, or whatever it is. You want to incorporate all of them so that it can give you now the best results. Like that is if you are unsure about which model to use. And then once you instantiate, then you can fit. To fit is like you're training now the models. Now remember, when you take 30%, it means that this 30% is for the testing. So here, when you train the model, remember fit is like you are training. So when you say fit, this tree, the one that you've instantiated, and then you use .fit, and then you say x train, then y train. Okay, x train, you need to have the x-axis and the y-axis. So if you take the X train and the Y train, then it's going to automatically utilize the 70%. So the remaining is for the testing. So here, these two, the X train and the Y train, is going to utilize the 70%. So the remaining here, it will be the X test and the Y test. X test for the X axis and then Y test for the Y axis. So it's going to utilize the 30%. And then once you do that, then you can do the prediction, model prediction. And then if you feel like, well, it's going to generate like those data so that you can have the, you can have the, you can have that line of best fit. Like you are going to have those, it's going to utilize now this testing is going to utilize, remember on the testing, remember on the training, you gave it both the X, okay, the features and the response, But then on the testing, you're just giving it what? You are just giving it the features so that the machine will be able to detect or maybe know what is the response. So when it generates the responses, and then you can have that line of best fit if it's in a linear regression or whatever model it is. Like it's going to have that that generated data. So you'll be using that predicted now, that line that is drawn, or maybe those distribution that is given out now to get now the feature prediction of the model. So here we are just trying to see the this okay, basically I say we have different other species. For example, the value counts, we can say we have different species here, and then there are several. There are several. And then once you see, okay, this, I'm not going to go into this, but on the matrix, this is a classification task, remember? So on this task, you'll be using now the precision. I said that precision is how good is this model at predicting the correct values. How good is it? And then now the recall is now how good is this model to be able to know that this is not good. This is wrong. And then now the F1 score is now the ability of the model to be able to detect like the correct from the wrong. Like it's going to involve like the precision and the recall. So these are the two. So we are getting these scores. This scores this the accuracy of the model. Yeah. So and again and also we have these random forests. Remember, it's going to follow the same logic. So that was just a quick overview on the machine learning. So now you're going to get these results. You're going to get these results, and then when you deploy the model, like you'll not want like to like for example, if someone wants to get the prediction, the model prediction, like they will not have to follow this whole process of training the model, importing the stuff here at the top, and then splitting and all do reading the files and all that. Like it's going to take a lot of time. It's going to take a lot of time. So in Python, you have a model called, or maybe a library called Pico, Pico library. So this Pico library is a tool that can save this model prediction. You can call Pico, or maybe let's try to define it. Like the Pico is like a module for serializing and deserializing the Python objects. Remember when I say object, this could be the list, the tuples dictionary, even strings, or even custom objects like those you create in a class. So this one is trying like to serialize. Serializing is like you are trying to convert like that state of a list, a dictionary into some form of bytes. Some bytes so that it can be easily transmitted to somewhere else, like electronically, or maybe through the like it can be transmitted, that way. So it's like a serializing in Pico. It's like you're trying to convert these for example, machine learning models or objects into those bytes, such that it can be easily transmitted. But then remember, it is in bytes. Remember, if you have worked with the APIs, and then you've learned something like RESTful APIs, which usually convert like the tables, which is in columns, rows and columns, into a JSON-like document. Remember, JSON is going to convert it like in the readable format, human readable format. But then on the Pickle, this one is trying to convert it into bytes such that it can be easily transmitted. Remember, bytes not that human language, it's like a computer language. And then once you serialize, then where you want to use it, for example, if it is in the front end you want to deploy, then now you'll be using what? You'll be using the deserializing, like you want now to revert it to the original state and then be able to use it wherever it is. So let me see. All right, so now I want us to, okay, first of all, is there a question up to that point? Because I want us to begin now the model deployment. Is there any question perhaps? Are we still together? Are you understanding? Am I too fast?
I think people are understanding.
Okay, all right, great. So now, remember now when you want to create any project, you need to have a directory. I see this project involves most, like it's more about the iris. Okay, iris plant prediction. Okay, species prediction. So I think it's a good practice to always place your project somewhere in a folder. And perhaps I can create a new folder and then I can call it the iris plant. Okay, plant. Okay. Okay, species. Okay, species. Let me just call it. I don't want to complicate things. Let me just open it in the VS Code. Let me see. Let me open it on the Visual Studio Code. First of all, let me close this one. Close folder. Open folder. Iris plant date modified. Yeah. So now, I said it's a good practice to always have a have a folder or maybe a directory where you're going to have a project so that you don't want to scatter things here and there. So we want to create a folder. So the main folder that's going to wrap everything is called the iris plant species. This is the main folder. Give me a second here. Okay, this is the main folder. And then under it, we can have another folder. Perhaps we call it models. Model. This is the model. So this is where we are going to place the model. And then we can create another one for, this should be outside at the root here. At the root here, in the root of iris plant species, I can create another folder called the template. So in the templates, this is where we are going to add in now the HTML files. And yeah, we're going to add in the HTML files here. And then another one, we can create now a file, not here the root. Okay, basically in the inside, we can have something like index.html. We'll talk about this HTML in a few, but let me just have some structure. Is a good practice to always have a proper plan before you begin to work on a project. And then here the root, again, I'm going to create now the main application to run this model. So I can call it, for example, app.py. App.py. And then another file is now that file that has okay, I think so this is fine. Now here the root, here the model, I can have a folder like that one for saving the model. I want to use now Python, not a notebook. So I can create now here a file in the model, for example, called save or whatever name .py. Save.py. This is where I want to save now to serialize the model. So first of all, I'm going to have these imports here at the top. I'm going to have these imports here at the top. These imports. But remember we said that Ensemble Learn is mostly the best. It's mostly the best because here you're trying to incorporate several heads, like several knowledge, so that we can get now the optimal output. So in this case, I will not use the decision tree classifier. I want to use the random forest because now this one involves several trees. There's one here. Let me just copy this model. And then remember now this is a .py file. .py file, let me just remove this one. And by the way, we don't need the metrics. Remember, you can always get the metrics here on the notebook, such that once you've settled with the model, then you can just save these files here. So I'm not going to use these metrics at the moment. I'm not going to use these metrics at the moment, but I can have here pcall. So I'm going to import pcall. Remember, it comes from Python by default. Import pcall, the pcall library. Like as a library, or maybe a module used for serializing and deserializing the Python object. And I said objects involves the list, tuples, dictionary, and all that. And then another thing is we need to have the data sets, and for the data sets, a data set, we are just using the same one. And you can notice here I'll not need the, sorry, I'll not need the head here. I'll not need to print out the head. I just need the data set, and I also need what? I also need the, I also need something called the features and the response, the predictor and the response are variables. Remember, when you drop here, it means that you're trying to access everything excluding this, these species here. You're dropping that one. And then now once you have that thing, then the next thing that you can have, of course, we need to transform. We need to transform so that it can be in the same scale. Remember, if it is a like you're involving several features, then you can what have different scales. Like you need to standardize. Like you need to always have it in the same. Otherwise, you will not get that accurate results. You need to standardize. So once you standardize, and then here we can try to do it. We can try to instantiate the model. Okay, not already. Remember this one we are trying to first of all standardize, but then now the next version here we are trying to do it. We are trying to instantiate now the decision tree, classify it. Oh, decision tree not should be the random forest. Sorry, did I import? Let me get the random forest here. Here it is. Let me have the random forest. And then perhaps here, let me just call this one scalar. Instead of standard scalar, let me just call it scalar. I like working with simple things, like things which are easy to understand. So these are the tools that okay, these are the important parts of this code. Actually, I've just extracted. Remember, first of all, you'll be using now the notebook. You'll be using now, remember the notebook provides access to having the visuals and all that. And then now once you've settled them with the model, like I've seen it has performed better, you have all those results, the metrics, you settle that this machine performs better, then what you do is now when you can now transfer those code to these other sites. The same I've done here. I've transferred now this code in this notebook. Give me just a second in here. Okay, sorry about that. So once again, we began by first of all importing the necessary modules. So you need this files NumPy for numerical. Did we use even here NumPy? Okay, let it be there. And then now we have this standardization. Then this, I don't think even this import is necessary here, but okay, let them be there. Then this now from this data set. The next thing you need to have the data sets, and then you need to have the features, and then the predictor, and then this the scalar, and then the instantiation of the decision tree. And then here we are training now the model. Remember, anytime you use the fit, it means that you are training the model. Now, the next thing now, we want to serialize. Remember, we're using this Pico library now to serialize. And I want to use the context management. Remember, we talked about file handling, though we have some new people. But in file handling this where, for example, you can use Python, for example, to read files, to write to files, and append and do all those operation where, for example, you say a file name, for example, open, then you specify the mode, the file name, and then the mode. But then I want to use the context management. It's easier here. It is easier. Let me use context management here for file handling. So I'm going to say with open instead of defining, for example, a variable, for example, a file name and all that. Let me just use a context management. So here, I'm going to specify a file and and at this file, should I place, let me just place it in the models. In these are models folder. So I'm going to say model. I'm going to use the relative path here, model folder, and then in the inside I can use let me just to be semantic, let me just use a name like a iris because it involves like a predicting the iris model. So let me just call it iris underscore model. But then now the extension for the pickle file, it is a PKL, and I told you that a serialization in this pickle library, it involves like converting the Python objects into some bytes, like a byte. So this is not a text format kind of stuff. So it is in binary format. So the mode here, it will be write binary. It will be write binary, but then let's use it as an alias. For example, model underscore file, model underscore file. Remember, I'm using it in the context management here, file handling here. And then now here, now I can now use now that pickle library. So I'm going to say pickle dot. Now here we are going to use now the dump like these models, once it's saved, like it's going to convert it into some form of bytes, and then I want us to to add those saved files in a file called iris underscore models.pk. So the function that I'm using here is now dump. This dump is like trying to add data to this file. So I'm going to use now the dump. And then now you need to specify the model that you're using. Now in this case, we are using this forest. Forest is the model that we have trained here. Remember, it is this one is for the random forest, and then this is the one that we have trained here. Whenever you use fit, it's like you are training the model. So forest, this one, I hope the spelling is clear, otherwise it will not work. So forest, okay, forest is there, is the model, and then forest is the model, and then we are saving it in this file called pickle, okay, iris underscore models.pkl. But then remember, we use it as an alias model.py. So I'm going to add in now the the file that we are going to dump this saved data, the saved prediction to this file called iris underscore model.pkl. But then remember, we've used it as an alias model underscore file. So it's going to be saved here in this file. So this is on the to save the model. Perhaps I can add in a comment. Perhaps let me say save the model. Now we need also to have for the scalar. Again, I'm going to use the context management way. So in this case, the other one I can call it, let me just call it scalar, or standard scalar dot pkl. Still we're using the right mode. Right mode, and then the file type is binary, a binary type. And then here we can just use instead of model name, just use something like a scalar file or whatever name it is, scalar underscore file. And then I'll need to just use the same name here. Here also, so the model here, it is, okay, the variable here, it is scalar. So remember, here is the one that we are using, like we have transformed our feature variables under this variable called scalar on the standard scalar. So I'm going to use this one here. And perhaps we can add in a print statement at the end so that we can know that the model it has completed it has completed to serialize. So perhaps let me add in something like a model and scalar saved successfully. A model and scalar saved successful. Remember this process for training the model, and this part is for saving the file. So I just want to save this file so that I can go now quickly to the other app now, so that we can create now the Flask application. So let me just quickly find the terminal. And I remember, if you have a question, you can just ask. You can just ask. So now, in this one, I want to access this saved file. So it is in the model folder, and under the model file, we have model, and then a model, then we have save. Is it backslash or I think it should be backslash, I guess. Save. In case it fails, I'll just do the / dot. Okay, first of all, you need to begin with the Python. You need to specify that you're trying to use Python. So Python, and then a model, then a save.py. Let me hope it works. So the decision is not defined. Decision tree. Decision tree is not okay. Yeah, yes. Oh, I forgot. It should be. Oh, sorry. Remember, here we're using the random forest, not decision tree. Not decision tree. I forgot. This is the issue with the copy pasting. Sometimes you forget. Forget, yeah. Let me try again to save the file. Oh, we forgot also. We forgot also to have this train test split. Let's have it. Could it be somewhere perhaps here before the model is trained? So remember, here we're just focusing on the training the model. Remember, on the testing, we did it on the notebook. Now here we just want to use now the trained. For example, we are certified that this is good. The model has performed better. And then we're just using now that values, those values here in the training. So we're not going to use now the predict here. We're just saving that state. Now let's again try. Yeah. The model has been saved successfully, but I'm guessing there's a problem. Oh, yeah, it's here. So you can see now it has created. Remember, when the write mode in file handling, like it creates the file if the file does not exist. If the file does not exist, it creates. Like if it exists, then it's going to overwrite. So now you can see that we have some kind of data. You can see even this what do we call it, Visual Studio Code. It cannot even read this one unless you have other extension. Like each file, it has these binary files inside it, so it is now saved. Any question up to there? Up to this point, we've just done what we've just saved now, the model, our model. So after you've saved the model, then you can use it. Is it clear up to that point?
Yes, it is clear.
Yeah, all right, great. So once again, serialization is like converting the Python objects into some bytes. So now once you've used it in the bytes format, so you can use it in any application now. So in the application that you'll be using, now you'll be deserializing, like reconverting it to the original state so that you can use it. So that's the work of the pickle. Like I think that's just the main thing that we've done here on the model, like I just saving that state. Now, another thing that we want to use here is now the Flask library. We have a very powerful Python framework called Django, but then that one wants like serious understanding of that nini. But we have another lightweight called Flask. Let me find Flask. Is it Flask? Py. So yeah, so this is the library, Flask, just a Python library to build a lightweight web application. So we are going to install this library. And first of all, guys, and I also encourage you guys, for example, if you are working on this kind of projects, you don't want to just install everything everywhere. Like you can see, you can notice that in this project, I've just created or maybe installed the project like everywhere. Otherwise, in future, you might want to have an environment where you're going to install like those files and place it in a certain directory, in a certain folder, like so that it may not be installed in the system. Because it has happened to me in most cases. Like another project, for example, depends on a particular version of Python, and then the other one does not depend on that. So, for example, when you are switching to different projects, then you're going to have a hard time. So, to solve that, like a Python has a way where you can create the environment, where you can have a project like just running within that environment. And to create that virtual environment, you can use Python, and then Python. Okay, let me say Python just in full. Python, then -m. Then the command to create the virtual environment is venv. Okay, venv. And then you can give it a name for that environment. Perhaps for me, I can call it env to represent the environment. So it's going to be created here. And under this environment, once it completes here, it's going to have some files. Okay, let me wait for it to finish, sorry. So in this env, we have these include, like these are the dependencies perhaps. And then this lib, like when you install something, is going to be listed in this lib. Like it's not going to your system installation directory is going to just be within this lib directory. Then the scripts. So this is where, for example, you can activate the virtual environment or deactivate the virtual environment. I'll talk about this one in details, for example, in future, but for example, if you want to activate, you can just use env and the folder name /. And then we are going to focus on the script because it has the files for activating the virtual environment. So you're saying scripts. And then inside that scripts folder, we have a file called activate.bat. So activate.bat. Activate.bat. So now when you run it, then you'll find out that the status of your command line has changed here to env. So it means now that you're working under the virtual environment. So once again, for example, let's say I want to install now that Flask library, this Flask library module, library that is. So if I install it here, then it's going to be within this lib folder. It's not going to go to my system. So it's going to like save those conflicts. So when I run, you will notice that it's going to install it here because it is running under the virtual environment, which is this env. So if you give it time, you'll notice that it has now come here, not at the system, at the root level of the system. So it's just a good practice to always not mix your project with the other things because you might have the dependency issue. You know, if you come to model deployment or anything involving like deploying on a server, it is very sensitive to matters versions. Because I might have a very powerful project working on your computer, but then when you deploy, it doesn't work because of the conflicts, or maybe the version that is there is not the one that you are using. You're using on the computer. So having everything like in its environment is very good. And then, for example, if you want to install, for example, somewhere on a server, you will need those dependencies for that project. you will need those dependencies, for example, so that you may know, so that the server will know like the dependencies that should run that project, for example, once you have deployed. So if you want to freeze the dependencies, you can use pip freeze, then freeze, then a / like that. Then you can specify the file name, for example, requirements .txt text file. So requirements.txt pip freeze, and then this angle bracket for greater than, then a requirements.txt. It's going to create here a file, and then it's going to list all the dependencies here. So when you install the, you can see here, when you install this Flask, it came with other files. You can notice that we have other things like this markup stuff. You can see it's here, like it has come with some other dependencies. That's why it is listed here. So now, for example, if you want to install it on a server, you will just be saying, for example, pip install, then requirements, okay, pip install. Then you need to specify that first of all you are reading the file -r. Okay, sorry. Pip install, then dash. First of all you read the file, and then you specify you want to install. For example, pip install -r requirements.txt, and then you'll be doing what is now. You can notice even we don't have here the NumPy and all those machine learning stuff, because now it is just running under this environment. So in the future, if you want to install it, just do like that. Then it's going to, now you can see it's telling me that the system is requirements already certified, because these packages are already there. So so we'll talk about this stuff in details in future because of time. Let me talk about now the Flask library. We have installed now the Flask library. I said it's just a lightweight Python framework for building the web applications. So now in this Flask, because we've installed now the dependence, or maybe the library. So here at the top, under the Flask, I can say, for example, from the Flask, like what I mean is that from this in the lib, we have a file called a folder called Flask, and then under this Flask, from Flask, I want to import. So this is the main file. I think this is the main file. So under it, we have some classes. So you have the classes, and the classes you also have other things. So I'm saying from the Flask folder, I want us to import the Flask. And also under it we have the, because for me, I've worked with this Flask for most of the time, so I don't need to just refer back and forth. But under that folder, the Flask, under that library Flask, we're importing the Flask, and also because I want to render also the template, the HTML template, so that you can see it on a web interface. So we can also have the render underscore template. And then also we need to have a request. This request is going to help us, like for example, if someone wants to predict something, they will be, for example, filling a form. Once they fill in a form, they will be clicking submit. So when they click submit, then the request is going to come here at the server, at the backend. Then the server-side language, in this case, the Flask, the Flask view is going to look for the relevant resource that the client, or maybe the user was requesting. Then it's going to return it as a HTTP response. So this one is going to help us to handle those kind of requests. And then we'll be returning the response in some sort of JSON. So I'm going to import now this module called the JSON. The JSON file, though we have other powerful ones, but let's just be simple. So these are the dependencies from the Flask. And then we need also to have the pickle library. In fact, what I'll do in the model, Let me just have this import here. Let me just have this stuff here at the top. Let me just have all those things here at the top. So now from this Flask, now we need to instantiate this Flask, that web framework, so that anything that we write here will be decorating with that Flask, such that it can be considered as a Python view function to handle the HTTP request in the response. So let me just get a variable called app, and then I'm going to instantiate this, or maybe create an instance of this Flask. Flask, but then when I'll be calling the function, or maybe when I'll be running the file, you remember how I was running this save? I was saying, for example, Python, then space, a model, and then inside save.py. So I do not want it like to run everything. I'll want it to run like a specific function. So this is considered a good practice. So under it, you can have the name, so that it's going to run only the ones that are decorated with these Flask okay object. So once I've done this, then I'll need to deserialize. Remember here we were serializing our model. Here we were serializing our model. So now where you want to use it now, you want to deserialize. To deserialize, like now to convert it now to the original state. For example, if it was a dictionary or maybe a tuple or whatever it is, so it's going to be returned in that state. So now you notice here we'll not be using the dump. We'll be using something called we will be using load. We'll be using the load, and then here is not write. Here it will be read. Remember the file name remain the same, but then here it is read mode, not write mode. Read mode. So this file up to this point it will be deserializing. Actually, it will be doing what? It will be deserializing these objects here, these saved models here. Yeah, so up to this point we are good. Now we can begin to write our code for the project. So you can have the routes. You can have the routes like, for example, let's say you have the landing page, you have the about page, you have the contact page. So those parts, they're at the top. I think you've ever come across, you visit our website, then you see you have the path here at the top. Yeah, these. So we need to specify these routes in some view function. Remember, if you come from Django, it is different. It is handled differently. But then this one is just a lightweight. We are just using it on the same. So first of all, we want to create a function. I'm going to create a function called a dif, and then this one is going to be for the home, and then it's going to be the route, just like at the landing, like when you, for example, you've ever come across when you just search a domain, for example, www.nemtech.com, then that page that is going to open when you click that domain is like at the landing page. So in this case, I want to this home to be like at the landing. That's why I added this forward slash, like just to be like I don't need to have the extension like for example .home or whatever it is. Like when you just click on the IP address or maybe the domain name, domain name, then it's going to take you to that page. And then here, okay, first of all, I want to decorate this home. Remember to make it a Flask view function. Then I'll need to decorate it with this app here that I've instantiated. So I'll use the @ symbol at app, and then a dot route. A dot route. Sorry. Sorry, you see this is just a normal Python function. So this part of the route is where it should be here. So this way you define now the path, not at the function. Remember, function is just the same way you work, you land on Python. Just create the Python function, and then I'm going to just return. I'm going to return what here? I'm going to return using the render template. I don't know why. Previously, when I was writing on the VS, it used to give me suggestion. I don't know what is happening here. I have to type the full name. So, so I'm going to use that render template, the render template, and the template that I'm going to use here, it is in a folder called templates. Okay, actually, you don't need to like this Flask, provided this app is at the root, when you have a folder called template, it's going to automatically know that that folder is very unique. It's going to, it has like those templates, those are files for the pages, the HTML files. So you don't need to specify the path to it, the relative path to it. So you can just specify, for example, if the file under the template folder is index.html, just say index.html. So you don't need even to specify, for example, templates and then the file name. So this is for the home route. And then now let me create another one. Still, I'm decorating it with the this up route cell. But then here, this one is going to be for the prediction, for the model prediction. So I'm going to say / and then predict. I think you've ever come across when you click on a page, like you'll see there, the path here, it will change. Let me see if, let me try to show you something. Let me just use NEHMTECH, NEHMTECH.com. Okay, NEHMTECH, Binrid is a domain. So you can see now this is the landing that I was talking about. Like when you just type a domain, it's going to open a particular page. So that page is like at the landing page. I don't know if it's my network or whatever it is, but or is it my network that has dropped? Am I still there? Are you able to hear me?
Yes, very clearly.
Oh, I think this thing has an issue with the loading, but I think you are understanding. Like when I say these routes, like for example, at the moment, assuming that this was NEHMTECH, www.nehmtech.com, and then when you click somewhere else, then you'll see there the path. For example, when you click here, help, you'll notice that here it has changed to help. Like you have this route, this main domain, but then these things are changing there at the top. So those are the things we call the routes. You click login, you see that thing changes there at the top. So those are the routes. So this is the landing, like when you just click the domain, is going to be here. Then another one is for the predict, but then this one is not going to be like I just want to create a simple one, like just a single page where you can fill in the form and predict better. You can add in many, like for example, for contact page, for about and all that, but this is just a very simple one. So this predict that I'm adding here is just an endpoint. This predict that I'm adding here is just an endpoint where it's going to like a call whatever function it is, for example, the function to predict the model and all that, but it's not going to be like for handling the specific template, something like that. Like it's just an endpoint where when I call it, it's going to trigger this function, and then the function that I'm going to create here in a few is going to predict the model. So I'm going to add in this route, but then I can add in another method called methods. So methods here that I'm going to use, actually just a method, is post. Post method, post request is like, for example, a server side, okay, or someone is trying to click on a form, then that form is going to send a request to the server. It's going to send a request to the server, like it's trying to save it in the database. That's a post request. Like you are sending something, or maybe the backend side, server side is trying to receive now information from the front end, and then it's going to save somewhere. It's going to save it somewhere. So that's the post request. And at the get request, this is, for example, you are requesting a resource. You are requesting a resource from the server, from the backend, such that you can get it on the front. So, for example, let's say you want to access this help. When you click this link, then this link is going to send a request a GET request to the backend that I want to see the help. So this one, the backend language is going to look for the relevant resource. Like for example, if the help page, then it's going to return to us here as a template, like this content. So this is a GET request, but then the POST request is, for example, you are registering somewhere. You're trying to fill in a name and all that. Then when you click on the submit, then it is saving that information to the backend. So that is a POST request. And POST request, this is in the event you are saving it to the backend. So this one, because now we want to save the information to the backend, and then at the same time we'll want it to return the response to see the prediction. But first of all, this predict is going to handle the POST request. Like when you fill in a form, you click submit, then it's going to save it, okay, check it on the backend, so it is receiving the information. So that's a POST request. Of course, I just duplicated this one, but I think I should have used predict. This is just some normal Python function. That's why I told you that's not even hard. But here, we can now try to write some complex query to handle the prediction. So in this predict function, I can use some exceptional handling here. Like, for example, let me say try. And then in this try, I can have features. Let me see if I still have the notebook here. So the features here is sepal length, sepal width, petal length, petal width. So these are my features. These are my features that I'm going to use it to get the spaces. So, and these features variable that I'm creating here, I can have here a list, and inside it, because those numbers are tuples, right? These numbers are tuples. So, oh no, sorry. Sorry, these are not tuples actually, they are float. Sorry, that's the word that I should have used, float, not tuple. Remember, tuple is like zile vitu ziko na parentheses and then you have the items like a sequence. But I'm talking about the float. Sorry about that. So, so we need to make sure that it is a float. So I can say float, float. Then, so the information that I'll be extracting, remember once someone click a post request, we are receiving what? We are receiving now the request from the front end. Remember we installed here a request here, which is going to help us to handle the request from the front end. So once we get the request, we want to extract some information. So the first one that will be extracting will be for example, the sepal length. We'll create a template where it's going to have a field for sepal length, sepal width, petal length, petal width, and all that, so that we can get the prediction. So in this case, under the request, a library that we say that is going to help us to handle those requests. So from the request.form, of which is the form that we'll be receiving from the front end, we'll be doing what we'll be extracting. And the first one is let me see. I think someone ananisaidia kushika. Someone can help me grasp these names. Sepal length, sepal width, petal length. Okay, actually petal sepal. So form, and then it was sepal underscore length, right? And if I write in my things, you can notify me. Is it that way? Length, is the length written like that? I'm not good in those things.
Length.
Is it so?
Okay. Interchange T and H.
Oh, okay. TH, like that?
Yes.
All right, thank you so much. Then it's a list, so you need to add in a comma at the end. Then the other one was width, right? Let me see if I can get it, the width. Is this the spelling for the width?
Yes.
Thank you. And then another one was petal. So I think what I'll be changing is just petal. I hope so. Is it okay? Are
Yes.
those the features? Okay, yeah, thank you.
Those were the features.
Okay, thank you so much. So these are the features. Remember now, here we'll be extracting this information from the front end request form, and then we're extracting. We're done like from this form, we'll be extracting this information. The sepal, like this first one, we'll be extracting the sepal length, sepal width. Remember, we'll create a template where it's going to have these fields. Now, we'll want like to flatten. Remember when we created this model. When we created the model, we used the standardized data. So we'll need to make sure that the data that we are receiving, that we want to use for prediction to predict, is also on the same scale. So I can say, I usually have issues with the spelling. That's why I always like copy pasting. So features, for example, I can call it scaled. A scale. I'm going to use something that I forgot. Something that I forgot. Now this is the issue with the copy pasting. So in this open, let me create a variable so that I can use it as a variable. For example, model, and then I assign it to this thing. This data so that I can use it as a variable, and then this one I can call it scalar, and then assign it. Okay, assign it to the same information there. So now here at the bottom, I can just use this scalar, which is some like something to help us to standardize or normalize. So feature scaled, I'll use scalar, and then I will be passing the transform from the standard scalar. We have the transform. So transform. By the way, guys, if I write my things, you can notify me. Sometimes when I usually talk and type, sometimes I can get confused. So in case things goes out, you can just inform me. So scalar.transform, and then so the features, these informations here, this data that we are receiving here. Remember, this one will be collecting those tuples, not tuples, sorry, floats, the floating number. So will be they'll be in their scales. So we want to like make it in the same scale. So this information I'll be passing under that standard scalar transform. So I'll just be passing this variable here, which is going to standardize, and then for the prediction. So for the prediction, we'll be using the other one. These are deserialized. Remember, we'll be using now this trained model now to get something. Remember, it's already saved. So we'll be just using from this saved. These are iris. So model dot predict from the scale. And you remember that near to fit in the model. When you fit in, we created the variable like all this information, like we have trained the model, so we have already saved the trained model. So here we will be just using the predict. Now remember, we just trained without any prediction. So now we want to get now the prediction after we've trained the model. So we'll be using now the predict from the sklearn. But then on the prediction, we'll not be using these features. We'll want to use now the scaled version. So I'll be passing this variable here under the predict. So the features, and I remember that in most cases you'll need to make sure that it is flattened. It is flattened. Remember, we have the pandas data frame, which can help you to flatten. Like, remember those columns when are many, you won't use it like that way. You need to flatten it so that you can only have X and Y. Even though you have several features or columns, you can flatten it so that it can be just like a one series, but you can access those other, informations. Other information, you can extract those other columns and all that, but you need to always first of all to do it to to flatten. So in this case, these features have stored all these lists like of all many information. So it is forming this in one like one series or maybe just one column, one row. So we're having just like at the X, like at the X. So these are like our X. So we want it to give us our Y. And I remember just one information. People will be just sending one information like when they fill in the form, the petal length, sepal length, it will be coming as one request. So it will be returning just one response, like one information prediction. So a model.predict, and then the feature scaled. So another thing that we can have here, we need to also check now the confidence of the model. Like we need to have something to tell us you remember those metrics on the classification. So we want to get like a data accuracy. Remember here we are using things like accuracy. In the classification task, we're using things like the accuracy, precision, F1 score, and all that. So I can create a variable probability. Let me assign it to model sklearn, which it has the the predict probability. Of course, I'll convert it to percentage format. Okay, it should be model dot predict proba. And remember here still I'm using what? I'm using this scaled. Remember these this scaled data here. So this for getting now the prediction for these features, for those data, this information. Feature scaled, and then now we need to identify like to go with the maximum probability. Remember, this is a random forest. Don't forget, we are using the random forest, and so we'll need to go with with the one that performs better, because it is a classification task. So we need to identify the one that has performed better. So for example, let me say max underscore probability, okay, like at those variable or maybe probability that is high. So we'll need to go with that. Perhaps let me use something like a formatted string so that we can have something descriptive in the front end. So perhaps in this one, I can have, let me round down such that if you have a number in percent, we'll convert it to the nearest. For example, if it's above 50, it will go to if it is, we don't want to have those decimals. Like for example, if the decimal is above 0.5, it will be rounded up. Then below it will be rounded down. So let's use now the round, and then here we'll be using the NumPy, which help us to handle the numerical part of Python. And then from the NumPy, we can use the max. I don't know if it's available also on the Python itself, but we'll be passing this probability that we'll be getting from these features. So we'll be using the proba, which proba this one, the variable. So it will be iterating and then finding out the maximum proba. But then we'll need to make sure that it is in percent format so that we can easily understand. People can easily understand. So I'm going to multiply by 100, and then perhaps with two decimal two decimal places, and then at the end perhaps I can add in some percent so that, for example, we can say it is 20% confidence level, 90%, and all that. So, and then we want to return. So once it has given us now the maximum probability, it has given us the prediction and the probability. So we want it now to return it to the client, to the user, the one who's using in the front end. So we're going to use the return statement. I believe you know this stuff. But then we'll be using this module called JSON file. A JSON file, like to make it in some form of Python object, like a dictionary, like stuff. So in this one, because it's going to help us have data in the form of a dictionary. So we are going to do what we are going to, first of all, store the prediction. It's going to return the prediction to the user, prediction, which is stored here, which is it is gotten here. How can I say that? Like this part is going to extract the prediction or get us the prediction. So this part, in fact, let me just use it. I'm not sure about myself. So let me just copy it to make sure that there's no typo or misspelling. We always like to do that most of the time. So this is the variable, the key, and then the value is going to just be that one, but then we'll want to get now the first one at index 1, because it's going to come like what do you call it, like a row and column. So we just want to get now the values, like I don't want to have it in the form of a row and column, so we just want to get now the value directly. So we'll be using this 0, which represents like at the row. Remember, it's just a row and column. So this one's like at the value itself at the row, comma, and then the second one is the probability. You will excuse me, I'll have to copy. Now, this one on the sorry. It shall be probability. Where is it? Okay, let me just type. It's not there. Let me just type is it probability or a probability? You can also teach me English. Is it like so?
Yes, that's right.
Okay, thank you. Now, on this probability, we'll be using this max proba. Remember, it will be getting out that maximum, the maximum probability, and all this functionality that I've done here, rounding, for example, up or down, then I'm multiplying by 100. So we're using this max. Initially, I need to configure my VS code, because it used to give me those snippets. Those, when you write, it gives you those suggestions. And I remember here I've used the the exceptional handling. So in this block, I need to have the except. Let me see where it is. This line, this line, this line. So it should be here. I need to have the except to catch the errors. So except. So in this except, I'll be having exception, and I hope this is the spelling exception as an alias E perhaps, and then we can return in case there's an error. We can have some error so that we can debug. We can see how we can get those errors. So we'll use still the JSON file. Okay, let me just type return JSON. Is it JSON file? Yeah, I think it's JSON file. Let me see. And there was somewhere JSON file somewhere. All right, no problem. JSON file, and then we'll pass it in the form of a dictionary. The key will be, for example, let's call it error, because it's going to catch the error, and then the value will be errors, but let's use this str. Remember, str function is going to help us like convert those statements or maybe that string in the standard UTF format, like something that you can easily understand. UTF format. Remember, we have different type of strings as well. So we are passing that in. And then, so on the run, actually we are done, but here on the run, we can say, for example, if underscore name is under the main, like this is very helpful. Like sometimes you don't want to like run everything, like execute everything. So we want to say, like for example, if the name is under the main, like a main, which is this file that is decorated with the Flask. this app. Remember here we passed it here the name. So anything that is decorated with this app, then we want to do what we want to run in the debug mode. Remember on development, you can have the debugs, but then when you deploy it on a server, on a live server, you won't need to add in the debugs. You don't want people to see the errors. So let me say app.run, but then in the debug mode. So I'm going to say debug, I'll give it true. Debug mode is going to be true. So actually this is it. This is it. Python exceptional proposal. It recommends that you need to make your work nice. So this is what we call this is the Flask file. This is the Flask file. Is there anyone with a question up to this point? Because I want to go now to the last part, or the HTML on the rendering itself, the file, the HTML. Is there anyone with a question up to this point? Are you understanding, or are you totally not understanding?
We are understanding some parts. Some parts I think we'll need to read a bit.
All right. Okay, no problem. All right, in case you have a question, feel free to just ask. So let me quickly go to the HTML. Remember, we'll provide the recording. I hope it's still recording, right?
Yes, it is.
Okay, thank you. So now we have created this file that has everything for the prediction and all that. So now we need to create now the HTML. The HTML stands for Hypertext Markup Language. It's not a programming language like Python, but it's just a language that help us to identify, for example, the structure of pages, web pages. For example, in a page you can have things like the title. You can have things like the form. You can have things like the paragraph, the link, and all this information. So this HTML, because there's no logic involved, it's just a language to identify those structures of pages, the structures of the web pages. So hey, actually it used to give me suggestion. I don't know what's the problem. So HTML. Okay, let me just switch to, HTML. I'll just switch the language mode here to the standard HTML, such that when I write here exclamation and then hit enter, it's going to give me the starter and the snippets here. So the first line of code, if I can go quickly, the first line of code defines which version of HTML you're using. Remember, you need to tell the browser that this is the current version of the HTML you're using. Remember, we have previous versions of HTML. So this first declaration, just tell the browser that you're using the latest version of HTML, which is HTML5. This version, this declaration. Then the second part, HTML defines that this document is an HTML document. This is an HTML document, and then this is just an attribute. You don't even need to have it here, but this is how you define the HTML elements. So these are called the HTML elements. So you have the starter tag and the start tag and the end tag, and the end tag is almost same to the start tag. The only difference that at the first angle bracket for less than, it has the forward slash at it at the start, and then the HTML, and then between the first start tag and the end tag, you have what we call the content. You have the content. So in this case, these are body and the head. These are now the content for this HTML. These are the, remember, this declaration is a self-closing tag. So it doesn't have the clause and all that. Remember, we still have the remnants of hex HTML, like a previous version of HTMLs, so which doesn't need the closing tags. We have the remnants, the current version of HTML, but these are the declaration. Okay, the start tag, the end tag, then the head. This is the information. For example, when you run when you run a page, you usually see something there near the favicon. For example, let's say iris plant species, okay, species prediction. Let me just try to run it quickly. Remember, this is not how you run the Flask templates, but let me just show you. You see these things at the top near this favicon. This is what we call the head. For example, let me try to say testing. You'll see it will be modified. Test. When I check there, you'll see now it is test. So anything that you write here at the head is just going to, it will involve like the meta information, like things to do with the SEO or maybe the responsiveness, or for example, if you want to include the styling and all those CDN and all the stuff, it will be listed here. But anything that you want it to be displayed on a page like this, then it should be under the body section. So the main part in the HTML, it is the head and the body. So the body, anything that I want it to be displayed on a page, you write it on a body. So the first part, you are defining that the string format that we are using in this document is the UTF standard string, and then this other one, like defines the responsiveness of this HTML to different devices. For example, it will be responsive based on the device, so that you may not have that overflow. Sometimes you have a page, when you have many content, like you'll see the content will go to the end, like you have to scroll down. So this one is going to help us, like for example, if the content exceed the width, it will begin in a new line. So like I did just want to help us identify the responsiveness of the page. And then I did just the title. It has the start tag, end tag, and then in between you have the content. So now in the body, let's just begin straight away. Guys, if you want to learn more about the HTML, I have the full course at the NEHMTECH.com. You can learn more about that because of time, that is. So in this one, I can have a heading. Okay, let me use something like a H2, which defines now the second largest heading. Perhaps let me call it iris. Okay, let me just copy. Iris plant species prediction. A species prediction. And then under it, I can have now the form. The form. Now, in this form, I'll need to specify the, actually I want to render it under, like I want to render it with the JavaScript. I'll use the DOM, I'll use the JavaScript here. So let me use an ID, have an ID so that I'll be rendering this form with the script, the JavaScript. So let me have a unique identifier for this form. So I can call it, for example, prediction perhaps, or whatever name, prediction. And then the action, actually I'll not need the action because we are going to specify the endpoint, the path. So we don't need this action. Like when you just click, it's going to send a request through an endpoint. These are predict. These are predict endpoint. So I don't need the action. So I'll just need this ID, then I'm going to render everything in a script in the JavaScript. So I just need to have that prediction. Perhaps let me call it prediction form to make sense. And then under this form, I can have some division. I have not explained these tags because of time, but I guess you can learn more about these things. It is free at the NEHMTECH. You can learn more about the HTML. But this div is just something to show that it's some sort of division. So in this division, the first one I'm going to use here, the label, a label. And when I just type like that, it's going to complete for me. So this one is going to be the label, because we are not submitting this form we are not submitting this form in a regular submit format. Like when we click on our form, then it's going, because it will be sending the request in a form of within the endpoint. So we don't need this for example, so that you can specify, you can link it with an input. So we don't even need this one. Let's just have the label. And then we can say, for example, the first one, I think it was sepal length, right? Sepal length. Length. Someone said it is. Is it? Is it like that?
LENG is like that.
Is it like this?
Yes.
Okay, thank you. So this is the sepal length, and then we can have also the input. So input, the input type here. Okay, let's just have an input. So the type, because this is people will be adding the numbers. Like for example, whatever number you remember when you train the model here. When you train the model, you're using these numbers, the floating point number. So so the type shouldn't be text. The type should be a number. The type should be a number, and then the name, the unique identifier. Let's use name. The name here we can use the sepal underscore. You need to use the exact name. Length. Hey, length. Length. Then I can add in also another one step. I can use 0.1. So okay, 0.1. And then we can also make it a required. We can add in some validation such that if you want to submit, if that field is not filled, then it's going to say like this field is a required field. So we add in this decorator here, the required decorator. Now let me just have another one. Let me just duplicate for several. I think there are 4. So the second one should be sepal width. I hope this is the spelling. And then this is where you need to be keen with, because you need to use these numbers.
A question.
Yes.
It's not case sensitive.
Which one?
Like for instance, you see the label, you're starting with capital S and capital W, but when you come to the input, the name is just small s and small w. So I'm wondering, is it not case sensitive?
Oh, this is where you need to be keen. Remember, this is just a label. Label like something like, for example, let's say you are telling a user that here you need to fill in what? You need to fill in the sepal length, like the information that you add here is the sepal length, like it's just a description, like just some helper text to to help a user understand that this field is for the sepal length, but it's not even used.
All right.
Yeah, but now what is mostly important is this information here, the name. Because when we'll be using the JavaScript, we'll be referring, like when we'll be sending the request, we'll be passing these arguments here, the sepal length, width, and all that. So these are the ones that you need to be very sure that they match. All right.
Okay.
So, and then here it should be petal, right? Petal length. So here, petal width. With, hey, let me see how I wrote the other one. Sometimes when I teach, but then when I type just randomly, like continuous, I don't have these issues. But when I teach and go slowly, I usually have these issues with the spellings. But so simple length with, so this should be petal length. This should be petal. Let me confirm something. Yeah, better it's written like that. Yeah. So let me hope everything is correct. Otherwise, even a single typo will cost you a lot of work to identify the issue. So these are the inputs. Remember, the HTML is just like a skeleton. Like I just used to define like a structures, but then I usually use a language like a CSS now to add in the styling, like for example, to add in the color, to increase the, to add in some margins here, padding and all those information, add in border radius. But at the moment, let's focus first of all on the functionality. Then we shall, we can add in some styling later perhaps. So at the end of this form, I can have an interface or a place where it's going to now display the prediction and also the what do you call it, the confidence level, or maybe the probability. So let me create a div dot hash result. Okay, I just want to create an ID, a division with an ID called a result, because I will be rendering this part with the script, JavaScript. So you need to have an ID, a unique identifier for this field. So we're using this ID. And then under it, we can have something like a I think H3. Okay, H3. And then in this H3, perhaps let me say predicted species. Predicted species. Predicted species, and then I can have a span. Don't know if you guys are just wondering, but HTML is not hard. If you want to learn more about HTML, remember materials are always available, including on YouTube and also on the NEHMTECH. I have all those things. So in this span, I can add in ID. This ID I can say, for example, prediction. Now here is where you need to be keen with the spelling. Prediction. Remember on the form, I use prediction form. Then I'm using the prediction, so you need to be keen. So here I'm not going to display anything here, this span, because I will be displaying dynamically with JavaScript. Like because we have this unique identifier, so it will be extending this tag. Like it will be displaying this information here. So I don't need to add in any content here because it will be filling from the backend. We are going to write a script in a few. And then the other one is the confidence of the model. So let me say confidence, or maybe probability. Okay, let me say confidence. The confidence of the model. So ID here, let me use probability. Probability. I hope this is spelling probability. Again, this one is also going to display dynamically from the backend. So at the moment, it will be plain. Like at the moment, when you go here, when you go here, it's going to be plain like that. This information is going to be filled from the backend. We'll be using that Flask. All right. So this is it. Now we can write we can now write the script. We can now write the script here. So in this script, from the JavaScript, we have some methods. We have some methods that we can use. So for example, to handle the DOM, we can use document dot get element by ID. So when you use this get element by ID, it's like a function which is going to help us identify like you can see in this case, we used an ID here called prediction. This prediction. So when you say document.get element by ID, you are referring to these element. These are a HTML element. So anything that you are writing here is going to target to unique identifier. For example, if it is, let's begin with the form. Let's begin with this form. So when you use this form, then it's going to affect the full form here. So this JavaScript is going to help us identify that element. So when I pass that prediction, it's going to, anything that I will be doing, it will be affecting that element, the form element there. But then in this one, we'll be using the event listener. I'm going to use from the JavaScript. Again, also I have a course on JavaScript. If you want to learn more about the events in JavaScript, I also have that one. Add event listener. Add event listener, and the action here would be, that's why we didn't add in the action on the other side. That's why we can just use the submit. We can use now the submit that we the submit that we so we, okay, something that I forgot. We need to have a button for submit. You notice here I don't have something where people can click so that you can send a request. So I need to have then before the closing of the form, I can have a button. I can have a button, and in this button, the type it's not going to be your normal button. So type is going to be submit, a submit button. When you click on it, then it's going to trigger something, like it's going to send a request. Perhaps you can say, for example, predict the species or something like that. Let me see. It should make sense. Remember, we shall style it later. At the moment, we just want to focus first of all with the functionality. So in this case, we don't need even to add in what. Okay, so basically this submit is the one that we'll be using. This is the action now. Remember, we did not pass the action here. We just used the ID. So the action that I will be using here at the JavaScript, it is submit this add event listener. Remember, we did not pass the action there so that we can use it with the JavaScript. So this add event listener, it's like we are trying to add in that action that we used to there. So instead of using it there directly, we are using it on JavaScript. And then we can as well use the async, because this request, we are sending it on a particular endpoint. So we can have this async. We can have the async, but then async, and then in this one, we can pass in the event as well. The event. Okay, let me try to minimize this one. And then, in this event, I'm going to specify now everything that I want to write under that form is going to follow here. So first of all, in that event, I want us to use another action here called prevent default. The prevent default. Prevent default, and then the second part, we can now specify the variables. Now in JavaScript is somehow different. It's not like in Python where you just define the variable as soon as you assign a value to a variable is created. In JavaScript, you have to specify what kind of a variable it is. Remember, in Python, it's dynamic. When you say, for example, app Flask, when you again try to say app and then you give it another name, it's going to dynamically switch to the latest version. But then in JavaScript, you need to specify the type of a variable you're trying to specify. For example, if you want to declare a variable which is unchangeable, you can use a const, which specify a constant variable. Like if you use that variable and then you try to redeclare again, it's going to throw an error. So I'm going to say this one. I'm going to say, for example, form data to collect to store the information, form information, and then new. I'm going to use form. Okay, form data from JavaScript. Form data, and then I'll be passing the event, and then the target. The target, of course, we are going to specify in a few. Specify that one in a few. But then now in JavaScript is not sensitive. Like you don't need to have these closings tag, but it's just a good practice. Remember, if you have come from a language like a C or whatever it is, it's sensitive to the closing tags. JavaScript is not sensitive, but it's just a good practice to show that you are terminating a statement or something like that. a program. Now, we need to have exceptional handling as well when we send the request, but the exception in JavaScript is somehow different from Python. So here we are using the curly braces. Remember in Python, we were using the this dot column. So here we're using the curly braces, and then here we can define out the endpoint. So the variable, again, I'll use the const, and then let me say response to handle the response from the server. Response, I hope it's the spelling. I'll use await, and then the method is fetch. And then the endpoint that I will be targeting. Remember, at the moment it's just at the same file, so I can just simply say predict. But if it's somewhere else, you'll need to specify the full path, including the endpoint, like at the full endpoint. But if I just say predict, it's going to automatically detect the IP address and then this endpoint. But otherwise, you'll have to specify the full domain, the full path IP address. So this one is going to trigger this function. The predict function, and then it's going to render all this information here, which is going to get us the prediction, the probability, and all this kind of stuff. So this is the endpoint. And then as we send this request, we'll need also to specify the method that we are sending to know that it's not a GET request. So we'll be sending the method. It should be post. Post, remember the post request is the information like the server is receiving. And then the GET is the one that you are requesting information from the server. You are the one who is requesting the information from the server. And then the body, we are using what? We are using the form data that we had defined up there, the form data that we specified here. So we are saying form data, the form data. And then we can also store the response data in a variable as well. So let me say const, then data, then I'll use await. But then this is going to be the response in a form of dictionary or JavaScript dictionary. So I'm going to use this as JSON. It's going to be an object. And then as well, we can have the if to handle the errors. It's not a must, but for me, I always like to do this so that I can catch errors. In the event there's an error, we can inform. It is usually helpful on the development to have this error so that you can easily detect the bugs and fix it. So here I'll just pass in the data. In the event you have the error, which is going to receive, remember this part is going to store the response from the server. So now, in the event, for example, the response from the server had an error, then we'll need to display this information as well in the form of an error. Remember the exception there. The exception here, we gave it error. So data.error and .error, we shall display it here. We shall display in the form of an alert JavaScript alert function where the key perhaps could be error. Okay. Okay, yeah. Let me just say it's just a normal tuple like that. And then error, I'll concatenate with the data.error above. Error, a good practice to terminate with a semicolon. Guys, we are finishing, don't worry. We are finishing. Good thing I'll provide the recording. So I'll again try to return, just directly return. Are you guys still there?
Yes, we are here.
All right, okay, thank you so much. I forgot, this is not a dictionary. So yeah, like this. And then, no, let me add in this colon here, then space here. That should make sense. So now we have everything. We have sent the request and all that. So now we need to specify these other part for the probability. Remember, we still have the ID and the probability and also the form. So, okay, the form we have already tackled it, but we need to have one for the results here for the prediction and the probability, these IDs. So at the end of this return, remember this return is now returning these responses, the errors, if the error was available. Otherwise, this information, because we want to render it dynamically from the backend, and we have this ID, we still need to use the document.get element by ID so that we can display this information with the DOM, like with the JavaScript dynamically. So here, after this return, we can have document dot get element by the ID, and then in the ID, the first one that was there, I think is prediction. You need to be it is sensitive to spellings. So this is the ID for that field for the prediction, and then the context here. I'm going to use the dot text context. Then I'm going to assign here to the data dot prediction from the backend. Remember the probability for the prediction is, in fact, let me just copy. It is prediction. The prediction set will be displaying those information there from the backend. Remember, this one is from the backend. Remember data, we define this data to store the information, the response from the backend. So within this data, we have a variable for storing the prediction, and then another one for probability. So when we say prediction, then it's going to trigger the display of the prediction there. And then another one for the probability. So the first probability it's here. Excuse me, I'll always have to copy paste to make sure that I'm very accurate. I have issues with the spelling, especially when I talk. Probability. And then one last is for the result. Now for the result, they will not use the context here because this is now the main one that is going to handle the entire results for the prediction and probability. So basically in this case, I can use the class list. I can say dot class list dot remove. So this one is going to help us. For example, if the information is not available, it's going to hide. For example, if you click on the submit, it's going to first of all hide, and then when the information is provided, then it's going to display. So I can make it hidden, perhaps by default hidden, remove hidden, such that we can have proper display of this conduct when it's provided from the backend. But we use the try, like in Python. When you use the try block, when you use the try block, you need to have the except. So here, the try in JavaScript, you can use the catch. You can use the catch. Catch, how is it written? Catch, yeah, catch like that, so that we can have the error. Whenever you use the try, you need to have the catch so that it can catch the error. It's very helpful for debugging the error, and we shall display these errors in the form of a dictionary. In fact, you can as well, but there is a good practice. For example, if it is on production, you can display the errors at the console so that it cannot appear on the front end. But because we are in the development environment, let's now display the errors at the front end so that it's going to give us a notification that there's an error, something like that. So let me say error. And then we shall concatenate with the error itself plus error dot message. Yeah, guys, finally we are done. Let me hope everything is okay. But now, remember here we are using it under the virtual environment. So we definitely need to import these module. So let me just say PAP. You're working under the virtual environment and doesn't have the pandas and all this stuff. So let's say PAP install NumPy. Another one is pandas. Another one is scikit. Is it scikit and okay, scikit-learn? Let me hope so. And what else? Okay, random forest. No, it is under the scikit-learn. Yeah, scikit-learn. I'm not sure about this scikit-learn. Let me first of all see if it will give me the error. Let me hope it just work. Okay, let me just see the documentation. Scikit-learn. Let me see how it is. PIP, PyPy should be. Yeah. Yeah, it is scikit-learn, yeah. Very correct. All right. So let's give it some second to finish. Let me see if people are sleeping or are still in the meeting. Wow, no, wonderful, wonderful, wonderful. Kwamko determined, you are very determined. That's wonderful. Yeah. Hey, I've talked for 3 hours. Congratulations to me. It's not easy.
Very true.
Yeah. So let's make it work. Once it works, then we can add in some bootstrap, some styling a bit, so that at least it can be nice. It can be nice. But if you want to learn more about the software engineering stuff, you can learn Django. Django is a very powerful and nice. It is easy to use, in fact, very easy to use. It handles the database stuff. You don't need to write complex code to create the database and tables and all that. And also, yeah, it's very, very, very nice. Very nice compared to other frameworks that follows the MVC design pattern. Remember, Django follows the MVT, and if you're using the API, then the template is going to be replaced by the JSON, so that those information to be rendered in the JSON format. Okay, nice one. But remember, anytime that you install any dependencies, you will need to list it in the requirements. Otherwise, when you deploy it, you will get an issue that, for example, a particular module is missing and all that. So you'll need to say PIP freeze. Anytime you do this, you need to have say PIP freeze, then hyphen, and then the file name, for example, requirement. Don't forget this part, requirements.txt. Remember, here is going to store also the version, so that when you want to deploy, then you'll need to install specific version. Like remember, these things are very dynamic. Like developers usually make upgrades to these modules, and you can find that the upgrade that they have made is not compatible with something else. So when you maintain it this way, then it's going to be nice. So it's going to create here, and the new dependency that we have installed, the NumPy, pandas, and all this information. So now we are good, such that in future, if you want to install these dependencies, just say pip install, install -r, then a requirements.txt, the same file, then it's going to install all these dependencies instead of going one by one and install this stuff. Now, this is nice. This is nice. This is nice. Oh yeah, it's fine. So now we can now run this Flask application by typing Python Remember, we don't run now this like this normal HTML format. We don't run it this way. You can see it has this extension.html. This is not a Flask template. So you run it this way. You run Python. You run Python, and then you specify the file app, the one that has Flask app.py. And the app.py, let me hope there are no bugs. It affects the bugs, sometimes very hectic. Let me hope. Wow, there must be. Okay, forest. All right. Let's see. Did I use forest on this file? Line 6. Line 6. Ah, okay. Oh, I get the reason. Now this is the issue with the copy pasting. This is now the issue with the copy pasting. Remember here, we are not writing. You know when you write a file is where you can specify where you want to place that file. But then now in this case we don't need to specify this are scalar, because already this scalar provided us the standardized results. And then also the model, this forest, it already gave us what, like it saved the model. So we don't need this forest and that scalar. So we only focus on this file name, this model file, which is analyzed for iris underscore model.pkl, and then this one. So we don't need those other variables. So let's again try to run. Now the goodness of having displaying the bugs, it helps you a lot to debug. So once again, let's try to see if there's another one. Wow, it has worked. So remember, it is going to give you this notification like this is a development server. Do not use it on production. Remember, on production, you'll make it false such that you don't see the bugs. Otherwise, the users will be able to see the errors. So it's going to generate you, for example, the local IP address. IP address is like a unique identifier for a particular resource. A particular resource, in this case, it is this web content. And I remember we said that the route, the landing, it is this one, the home, which is the term index.html. So it means that when you just click on this endpoint that Flask has provided, then it's going to open that content. Yeah, you can see now it's providing this landing page without any other extension. So let's try to see if our things is working or not. So let's add in, for example, let me try to find the petal length, sepal length. Hebu kuna mtu anaweza shika hizi vitu 5.1, 3.5. Okay, let's say 5.1. Ingine imekuwa nini? What was the other? My memory is not that good.
3.5.
3.5. Then the other
1.2, 1.4, and
1.4. Okay, is it the length? You know, it also is it the sepal length width? Is it in that hierarchy? Length, width. Okay,
Yes.
petal length. Length. This one was
1.4. 1.4.
And then lastly
0.2.
0.2. Let's hope it works. Wow, it has worked. Wow. Congratulations to us.
Is that 100% confidence level?
Yeah, 100% confidence level, because I've just used it okay, let me try to perhaps say here 1, then here perhaps 6, and then here, for example, 0.3. 0. Okay. Okay, let me just, okay, I think I had to refresh. Okay, let me say something like 3. Like I don't want it to be 100. I want to see if the confidence level will change if the values change. Width will be Okay, with the other one was, the original was ranging between 3.5. Okay, let me use something like 1.3, and then this other one, for example, 2.5. Then the other one was, let me just use 2.0, something like that. Yeah, you can see it's working. Yeah, it's working. So what is mostly important, it is in this notebook. So this is where you can train the model. And for example, if you feel like the accuracy, remember here it's a classification task. So it uses stuff like the precision, recall, F1 score, accuracy, and stuff like that. So you will be, for example, if it's not accurate, you might want to consider, for example, doing the ensemble learning. For example, if it is a decision tree, you might want to also, if it is in classification task, you can use the support vector machine as well. You can try to use the logistic. For example, if it is a one feature, one variable. And if those things that don't work well, then you can try the hyperparameter tuning. For example, if it is a random forest, and the number of estimators, for example, the number of trees that for example, if you increase to 100, you find that the model is not that accurate, you might want to reduce. Or, for example, if the tree, you want the tree to grow to 2 branches. For example, when it is 5 branches, it includes the noise. The noise, like those things which don't contribute to immensely to the model prediction. So you might want to prune. When you prune, like when you reduce the branch, okay, the depth, the depth of a tree, like it will be helping a lot on the model. But I'll talk, I think, in details about the machine learning when we reach there. About the machine learning, we'll talk about those things in details. But at the moment, let's try to finalize these things by adding some styling. Some styling. I think I can use the bootstrap because that is just copy paste. Let me just use a bootstrap styling. Get bootstrap.com. Actually, I used Bootstrap long ago. I usually code with Tailwind CSS. Is a very powerful one. I think I've forgotten already Bootstrap. Offhead. So let me just use it as a CDN, a content delivery, so that we don't need to install this stuff. We don't want to have our file to be a hectic. But now the disadvantage of CDN, working with the CDN, like it will depend on the internet because it is getting this styling from somewhere else. So disadvantage here, you'll need to, for example, if you are running locally, you need to have an access to an internet for it to have those styling. But when you install it, you'll have it in the computer, so you'll not need to have an internet. But because I don't want to go into a lot of work, let me have this styling. So I say that any information, the meta, data, SEO, and all those information, you can add it at the head. Remember, head is not something that is going to be displayed at the body section, but at the what? Okay, let me just add in here. There's when I just type link, I think it's going to complete for me. Okay, let me change to HTML, language mode to HTML, so that it can give me the snippets, such that when I just write here link, it's going to give me all the attributes within the link, including the style sheet and all these CDN. Let me just paste there. But I can as well use the custom style in CSS to add in the style, but you'll need to specify the folder for the static so that you can add in, and it's a long process. So let's just use the bootstrap, the copy and paste, so that the CSS and then the script. Do we need even the JavaScript here? Okay, let me just have it. Yeah, let me just have it so that I can show you something. So sometimes you might want to have these things at the top, this navigation bar at the top. So in that case, you'll need a JavaScript. So it should come here at the top, at the very bottom. You make sure that the JavaScript always load at the very bottom. Don't add JavaScript in the midst of your HTML element. So make sure that the JavaScript files are always at the very bottom. Otherwise, it will be rendering the scripts. It will be rendering the scripts without even completing, for example, let's say you were to render this submit, and then perhaps you have other functions at the top or maybe other elements. So JavaScript, the code, the pages, it will be struggling to render this part before loading the other content at the bottom. So it's going to have a lot of issues. So you make sure that the scripts are always here at the very bottom. And then now that I have that, now in the event, for example, you want to add in the navigation. Okay, I don't think I shouldn't complicate this. Okay, let me try. Let me have a nav bar so that I can just show you how you can add in, but I'm not going to focus into that. Let me have, there's something called a nav bar. Yeah, here it is. So it's going to give you these snippets. For example, this format, you can just copy because you have already included the bootstrap. You can simply just add there. And then when you go to your browser, where the project is, you'll find out that you have this page here at the top. You can see it has all its styling without even coding. So yours it will be just to change the names and all that. Now this is the advantage of having the bootstrap. But then in this case, I don't want to go into that. I just want to have to style these things in a few and then make things work out. So now to so this one I can add in the class. And then in this class, I can use the bootstrap margin top 4 pixel from the bootstrap. So this one is trying to help us add in some margin here at the top. And then for the form, let me add in also the class. And then margin, general margin. Okay, margin start. I don't know if it's margin start. It is in tailwind as well. So margin start, let me try 4. I'm not sure if it's start or left. Yeah, it is start. Margin start. And then, so on these inputs, oh, not inputs actually. Okay, yeah, it should be here. So class, I'll be using form, I think form control to have a proper styling of this stuff. Let me see if it's, let me just add it to all of them, all of the inputs have similar styling. Let me first of all see if it is properly styled. Yeah, it is properly styled, but we need to also have margin end here. Margin end, we can also use 4 so that it may not go up to the end here. And then at this one, we can add it to the sender. This text to be at the sender. We have the UI design. You can help me. Those people are good in the user interface stuff. So let me add in another text. Sender, just to make sure that it works well. And then this button at the bottom, where's the submit button? Yeah, here it is. So class, it is a button. We are using BTN, then a BTN primary. A BTN primary, and then a margin top. Margin top. I don't know if it's top. Okay, margin top is 4 pixels. Let's see. Yeah, top is 4 pixels. I think also let me add in bottom. Margin bottom 4 pixels so that we may also have some margins here at the bottom. And then this other one as well, I think it is in a div. We can add in the margin. Okay, class name first. Class margin start. Margin start should be what? 4 for consistency. Then a margin end also 4. 4 pixel for uniformity. And then I think we can add in some background color at least to distinguish that this part is for the input. So I think I can use the BG body secondary from the bootstrap. I don't know if it is in bootstrap or tailwind. I used to bootstrap long ago. I think it's not bad. Let me have rounded Okay, rounded. So the border radius to be rounded. And then what else? Padding, the space surrounding it. So padding, let me give it also 4. And then the boot plans, let's try 5.1, 3.2, 3.2, and then okay, 3.2. And then petal length 1.2, 0.3. So I think which UI will help us, like which thing that can help us to make it beautiful? Can we change this color, or how can we make it to stand out a bit? Or the text size we reduce?
No, don't reduce the text size. Maybe we put a vibrant color.
The color. Okay, let's also, okay, let me first of all let me use first of all H4 because this is not the main subject, the main content. Remember, we have the main heading. So if you have the main heading and the content here is almost the same height, it's not a good UI. So let's just try to reduce a bit. But this span, as you've said, we can try to add in some color. So so for this span, okay, this for the predicted species, we can use what? Which color can we use for the prediction? Can green work? Green, right?
Yeah, let's use green.
Yeah, so it is BG. I think body, I'm not sure. Success. Not actually, it should be just text. This is the text. Actually, this is the text. Text success. Success. And then this other one will use what? For the confidence. Can we use okay, what is the color for tertiary? Okay, not sure. Let's see. 4.2, 3.1, 7.3, 1.2. I know this one is going to perform poorly. Okay, this is not the color. I think which color can suit here? Can which color guys do you think can work best here?
Maybe red, so that if it is low, you can't do that. If it is maybe more than 50%, you're good, or less than 50%, you're not good. That doesn't work.
Oh, yeah, it is possible, but then that way you'll have to do the conditional.
Yeah.
And I think it's going to take us time. You'll have to write some conditional statements.
Then let it just be green like the one above, so that it
Oh,
is
yeah,
not
sure.
too much.
Sure. Let's just okay, let's just use success as well. And then for the heading, what is the complements of these colors? Green and blue. Which color can we use here? Can blue or red? Can the title be red? Are we use also green?
Let's stick to those two colors, blue and green.
Yeah,
I
so
feel like
let's
if
use
we
that.
do red, it will be too much.
Yeah, sure. It will be oversaturated with color, so success. And then something that I is also making this form, this thing look bad. I think it is this form. Perhaps we can make it we can reduce some things so that at least it may not look like you copied the code somewhere. So perhaps we can reduce the code, and then and also this disable, I think. Why is the stat tag? And then this is the drop down or okay, home. Then perhaps let's just call it something like about. Where are we? Home. Then instead of link like about, even though it's placeholder, but it will make more sense than just being those dummy stuff. So I think it's not bad, right?
Yes, it looks decent.
Yeah.
It's good.
This is just a starter. Like the key thing, I'm not into the UI. I just wanted to show you how to render the model's prediction now on a front end, something where people can interact with it, so that for example, when you have something like that and then you deploy, and then you tell people to, for example, to test your model. For example, if they want to test, for example, the sepal length and all this information, then it's going to give them like some result. Like they will be more confident with you, like what you are doing. Like people will guess that indeed this is a machine learning. It's trying to predict something. But then when you just present things in a notebook this way, I think people will see like there's a lot of complication and stuff like that. People want things here and now. So
Yeah.
when you have an interface where people can interact with it, then I think it can be quite nice. Yeah. So guys, this is what I wanted to show you. Like this is a very simple way, but you have also Django where you can store this information in the database such that you can use the information that the people are submitting and then retrain the model so that in future it will perform better. But I just wanted to show you how to use the Flask. Is a very lightweight web application where we can now render these machine learning models to the front end, and people can interact with the models, and you can push it to the GitHub, then it will be nice. So guys, that was it. That is it.
Awesome.
Yeah.
So you're saying
Thank
if I want to, if say if I use Django, I can
Yes.
retrain my model to perfect it.
Yes, yes. You can save. In fact, Django gives you the models already. Like I just specify them, the fields, and then the information that people are submitting. Like for example, when people send the the post request, you will be saving it in the database using the save
Okay.
method in Django, so that you can have those information in the database, and then later you can use those information that people are submitting. Then you can later try to update the model to optimize or maybe retrain and do such kind of stuff. So it can help. It's very powerful, Django.
Oh, okay. How long does
Yeah.
it take to learn Django?
Yeah.
I'm just curious.
So sometimes it depends with oneself.
Mm-hmm.
Like someone like me, for example, I've learned a lot of languages. So if I want to learn a tool like a framework like Django, it won't take me. For example, assuming I haven't learned Django before, it won't take me more than 2 weeks because
Awesome.
I already have the
Oh,
backgrounds on
okay.
those other things. But someone who is new,
Mm-hmm.
it can take some time. But if you're good in Python.
Oh,
If you're good in Python, then it won't take you, I think, more than 3 months, provided you're good in Python. Remember, just a Python framework. So it's using just, remember here also on Flask, we've been writing just Python code. These
yeah.
are just normal Python code. So you need to have the knowledge of Python.
Okay.
Once you have Python knowledge, then to understand the Django or Flask or any other Python framework, it's not going to be difficult.
Oh, okay.
Yeah. Any other question?
No. I think I'll
Mm.
have to practice, and then now I
Yes.
can get more question. No, practice is what
Yeah.
makes you know whether you're good or you need to do
Yes.
more
Yes.
work.
Yeah.
Yeah.
Sure. Are you Nemo?
No, I'm Ingrid.
Oh, okay. Your voice sounds like a Nemo.
Oh,
All right.
okay.
So, any other question from other people? Victor, Peter, Emmanuel, Vivian, Virginia? Have you learned something, or was I too fast? And by the way, I have to tell you that I'm a lawyer. Sometimes I've been saying things Perhaps you didn't get it well. So I don't know. But guys, I'll share the recording in case you want to review. You can always I'll share in the YouTube. You'll find the recording there. But this was just a crash course. You will need to review it, rewatch it several times. But when we reach to machine learning, I'll teach you Django, like a step by step, like from in a beginner steps. But this was just a crash course because I want to go home. I wanted to teach it so that someone can have something on their portfolio. But we'll learn more or in details about this thing when my time will reach to teach. Otherwise, mkuwe na usiku njema sana.
Sawa sawa. Thank you and good night.
Good night.